Hi everyone, here is part 2 of our note, 6.3 day 2. So it says a baseball is hit with an initial velocity of 130 feet per second from 4 feet above the ground. The ball is hit at an angle of 25 degrees with the horizontal toward a 25-foot fence that is 350 feet from home plate. We want to know if it's a home run. So I'm just going to show you the simulation. I went to mode, degree mode, because it's 25 degrees. Notice this time I decided to put my calculator in sequential mode. The reason why is I actually first graphed the fence, and then we're going to graph the path of the ball, so that's not building the fence as the ball is hit, and we will see if it's a home run. So here goes, everyone. So there's the fence, and here comes the ball. Very good. Okay, so X and Y. The X is the horizontal component of the ball, and the Y is the vertical component of the ball. X and Y both are in terms of time t. It looks pretty close. So let's go ahead and do the algebra. So first of all, we have a ball, and it's hit at it comes off the bat at a 25-degree angle. And again, with the horizontal, we're going to describe the X and the Y. So the cosine of 25 is X. Oh, we have to figure out. So notice that it's 130 feet per second, but distance is rate times time. So we would say 130 t, because again, we were talking about distances. How far did the ball go? How high is it? So we want to consider the path of the ball, and we want to think about a distance. So we have X over 130 t, and the sine of 25 is y over 130t. So that's how we get our equations. Now, don't forget that our projectile motion equation, so we're going to consider that for the vertical component of the path of the ball, because again, gravity does not affect the horizontal component. So we need to think of the projectile motion formula for our y equation, and the initial height was 4. We're not golfing. So there you go. Now here's the fence, and again, I put that in y1. The fence is 350 feet away. And I decided to go for 5 seconds for my simulation. That just made sense to me. You know, again, that's kind of arbitrary. We could have picked some other number, I'm sure. But then if I want the fence to be 25 feet high, you could write 5t, because 5 times 5 is 25. There's another, or if you wanted to, you could have said like 25 minus 5t, something like that, to start at 25 and graph. But again, either way, I'm going to do this, and my fence is going to be 25 feet high. So let's think about the algebra. Step 1, I want to know how long it takes to reach the fence. So when x equals 350, that's how many feet away the fence is, I need to find t. So if I type this into my calculator, it took 2.97 seconds to reach the fence. Then step 2, I want to know how high it is, so I'm going to let t equal 2.97 seconds and find y. So if I type that into my y equation, I get, let's see, 130 times 2.97 sine of 25 minus 16 times 2.97 squared plus 4. I end up with 26.013 feet. So yes, it does clear the fence. So let's just take a look at the calculator again. So here's my window. I decided again to go for 5 seconds, which was plenty since it took 2.97 seconds to get to the fence. The t step, so I'm making a calculation every 0.01 second. And again, I wanted my speed to be just right. I didn't want to go too slow or too fast for the simulation. The fence was 350 feet away, so I went 360 for my x. And again, I wasn't really sure how high the ball went, but 55 feet was good enough. Let's take a look at the equations. So notice I put the fence in first, and it built the fence, and then the path of the ball. So we could look at the graph one more time. Here we go. There's the fence, and here comes the ball, and it was a home run. Home run.